Today's goal is to define heat and tell how thermal energy and heat are related. Temperature is the measure of how hot or cold an object is. In other words, the measure of the kinetic energy of an object. Again, temperature is related to the average kinetic energy of the particles of an object. Look at the two blocks below. You will notice that on the right, there is longer arrows in between each particle. This means that these particles have a higher average speed than the shorter arrows of the particles on the left. Therefore, the particles on the right would have more average kinetic energy. So let's discuss how temperature changes. First of all, as an object heats up, its particles move faster, and as a result of this, the average kinetic energy increases. So, of course, then the temperature increases as well. Let's demonstrate this idea. We have a cup of sand that's been sitting here for a while. If we shake it for a while, you can pass it from one to the other. The particles are now being shaken, thus they are moving and now have kinetic energy. Before we do this, let's measure the temperature of the sand to see what it is. Okay, as you note that the sand is room temperature. Now as we're passing it along, shaking it, here in a few minutes, we'll take the temperature again. Since the particles have a high kinetic energy due to their movement, we would note, or should note, a raise in the temperature of the sand, because the average kinetic energy has raised, thus the temperature must raise. Recall that thermal energy is the total energy of all the atoms and molecules in a substance, or in other words, the sum of the kinetic and potential energy in an object. Recall that thermal energy depends on mass and temperature. Let's consider a scenario here. Which has more thermal energy, a cup of coffee or a pot of coffee? If you said the pot of coffee, you are correct. Now, let's consider why is this so. If you remember our discussion from yesterday and today, you would have said that the reason the pot of coffee has more thermal energy is because it has more mass than a smaller cup of coffee. Let's consider another example here. Which has more thermal energy, a cup of hot tea or a cup of iced tea? Let's consider another example. Which has more thermal energy, a cup of hot tea or a cup of iced tea? If you said the cup of hot tea, let's consider why. So why does the cup of hot tea have more thermal energy? It's because it has a higher temperature. Now let's consider heat again. We're trying to figure out here what is the relationship between heat and thermal energy. Well, heat is the transfer of thermal energy from one object to another because of a temperature difference. See the graphic below. Thermal energy always flows from a warmer to a cooler object. Consider this picture. You're in your house, and then the tree is outside. Which place is going to be cooler? Okay, yes, it would be the inside, because most likely you have cooling systems such as an air conditioner, and the outside, of course, is going to be a little hotter. Where is the heat going to transfer from and to? It would make sense for the heat to transfer from outside to your inside, because it's hotter outside than it is on the inside, recalling that temperature always flows from hotter objects to cooler objects, or from hotter locations to cooler locations. Have you noticed that some objects just seem to heat better than others? Well, if so, you are experiencing conductors. Conductors are just objects that conduct thermal energy well. Some common things things that are conductors include metal, any sort of metal, aluminum, gold, silver. All of these objects conduct heat well. Water actually conducts heat well too. There are many conductors that you experience every day. On the other hand, there are those items that are insulators. They are poor conductors of heat. Some examples are wooden spoons. Also, even the big thermal carrier that you can put ice in and food in, it's a poor conductor of heat. That's why your ice stays frozen, your food can stay cool. If you've ever packed a thermos for lunch, you've also experienced something that is a poor conductor